In this video, we will look at some of the textbook exercise problems from section 3.3. So this, one second. So this section deals with basic differentiation rules. So all that we are going to see in this particular set of exercise problems are just the application of the power rule. That's it. So what is the power rule? Power rule states that if you have a function, let's say f of x is x to the power of some integer n or some real number n, then its derivative f prime is given as n times x to the power of n minus 1. So what this says is that the derivative function is nothing but the original power multiplied by the variable raised to the power of one number less in the power, right? So the power drops down by 1 when you take the derivative. So this is the idea, and this is what we are going to use on all of these problems here. So in the first question, the function given to you is a constant function. So if you were to graph f of x equals 5, the graph will just look like this, right? So f of x equals 5 is like this. It's a horizontal line, right? So you know that intuitively, this particular function doesn't change at all, right? So if you were to take any two x values and you see how much the function has changed in that interval, the change is 0, right? Which means that f prime, which is the notation we are going to use to indicate a derivative, f prime of x is 0. So this follows a rule, and the rule is that the derivative of any constant function is always 0. Now that takes us to the next problem, which is a polynomial function. And this polynomial function comprises of many monomials of different degrees, correct? So we will just apply power rule to every single term, and together we will be applying the sum and difference rule, okay? So let's see how this goes. So f prime is nothing but, we use the constant multiple rule, which means if you have this variable multiplied with this constant, and if you're taking the derivative of that, bring the constant down as is, don't touch it, then apply the power rule to x to the power of 4. So if you apply the power rule, it becomes 4x to the power of 3, okay? Minus, bring the 32 as is and take the derivative of x. X has a power 1 raised to it, right? So the derivative of x by itself is nothing but the old power times the variable raised to the power of 1 power less. And anything raised to the power of 0 is 1. So this is just 1, right? So the derivative of x is just 1, and therefore this is 32 multiplied with just 1. And remember, 4 cubed is just a constant. There is no variable in there. And you already know that the derivative of any constant is 0. Now, if you simplify all of this derivative becomes 10 times 4 is 40. So 40x cubed minus 32 is f prime. So f prime is nothing but 40x cubed minus 32. Okay, now that takes us to the next problem in this set, where you are just simply using the power rule to take the derivative. Now, square root of t, right, can be rewritten as t to the power of 1/2. So square root, when written as a rational exponent, is just 1/2 power. So when you take this derivative, this becomes 1/2 t to the power of -1/2. Okay. Now, that is nothing but, so the t to the power of negative half is nothing but 1 t to the power of positive 1 half in the denominator, right? So t to the power of negative 1 half is nothing but 1 over t to the power of positive 1 half. So which means this can be written as 1 over 2 root t, right? So we change it back into the radical once we have finished taking the derivative. Does this make sense? So first convert it into a rational exponent, apply the power rule, then change it into a positive exponent so you can rewrite it as a radical again. Okay, so now putting it all together, this 4 comes down as is, you're not touching it. The derivative of square root of t is 1 over 2 times square root of t. Then the 1/4 comes down. The derivative of t to the power of 4 is 4t cubed. The derivative of t is 1. The derivative of 1 is 0. So if you simplify this, what happens is this reduces, right? So your final answer will be 2 so the final answer is 2 over root t minus t cubed plus 1, because this 4 and 4 gets cancelled. So that is your S prime. So please pay attention to notations. Do not start taking the derivative of S of t without writing S prime of t is equal to. Okay, so those are simple things to follow. Otherwise, your answer will be completely wrong. So you make sure that you follow correct notations. And yes, that's the main thing. You have to follow notations properly. Moving on to the next question. Here, the question gave you a product. So this polynomial is not expanded for you. It is written in the factored form, or rather a product form. So the question is asking you to first expand it, combine the like terms before you apply the power rule. All right. So don't apply the power rule on a product. First expand, convert it into sum and difference before you apply the power rule. So let's do that first. So I'm just rewriting f of x. I have not started taking the derivative yet. So all I'm doing is I'm applying the FOIL. So square root of x times square root of x is just x, and this is minus root x plus root x minus 1. So this and this gets cancelled away. So my original polynomial is nothing but x minus 1. Now I take its derivative. The derivative of x is 1, 1 is 0. Therefore, my final answer is f prime of x is equal to 1. Okay, I'm going to do the same thing in the next problem. I'm going to distribute it first. Now, if you find it difficult when a radical and a rational exponent are written together, you can feel free to rewrite them both in one form. So basically, I'm rewriting this as a rational exponent first. Okay. Then when I distribute it, what happens? So I distribute it like this. X to the power of 1 half times x to the power of 1 half is x to the power of half plus half, which is just x to the power of 1, right? So this becomes x minus 3 halves plus half is 4 halves, which is 2. So this becomes this. So this is your original function. So when you distribute it, this is what it becomes. And then you take the derivative, and the derivative is 1 minus 2x. Okay. Now, in the next problem, again, we have to simplify it first before we can do anything with it. In order to do that, I'm going to factor my numerator. The factors of my numerator are these. And then I divide it by square root of x minus square root of a. So this and this gets cancelled away. So my original function is square root of x minus plus square root of a. And in the problem, they had already told you that a was a positive integer or something like that. So they have specified that it is a number, okay? So keeping that in mind, I take the derivative and y prime is nothing but 1 over 2 root x because the derivative of square root of a is just 0. It is a constant. So this derivative is nothing but 1 over 2 root x. Okay. So then in this next problem, you are asked to find the equation of a tangent line, and then just for your own purpose of just for learning purposes, you may go to desmos.com and you can graph f of x equals negative 3x squared plus 2. And then once you have the equation of the tangent line, you can do that as well and see how they both look together. Okay. So let's do this. I'm going to take this derivative. This is what I get. I evaluate this derivative at an x value of 1, and that gives me the slope of the tangent line at x value of 1, which is negative 6. Okay. Then I also evaluate my original function at x value of 1. So if I substitute it, then I will have negative 3 times 1 is negative 3 plus 2 is negative 1. Okay. So then the equation of the tangent line is nothing but y minus y1 is mx minus x1. My y1 was negative 1, my slope was negative 6, and my x1 was 1. So I simplify this. This becomes y plus 1 is equal to negative 6x plus 6. I do some rearranging to write this as negative 6x plus 5 is the equation of the tangent line. Okay, so now if you were to graph this, how will this look like? Negative 3x squared plus 2 graph is going to be something like this, right? And negative 6x plus 5. So this is at a is equal to 1. So 1, negative 1 was a value on your graph. So that's somewhere here, right? 1, negative 1 is here. And then the equation of the tangent line was negative 6x plus 5. So your tangent line is probably going to go like this, right? So this is a badly drawn graph, but this is how it will be. And you can check that on your Desmos, okay? All right. So in the next problem, you're given a polynomial function. The part A of the question is asking you to find all points on the graph at which the tangent line is horizontal. So when you have a horizontal tangent line, that means the slope of the tangent line is equal to 0. Or in other words, f prime is equal to 0 at those x values. So the step one, what I do for this problem is I find f prime of x first, and that is 6x squared minus 6x minus 12. So to find where I have horizontal tangent lines, I will have to set f prime to be equal to 0 and solve for x. So I do that. I set it equal to 0. I factor the 6 out. I factor this further, and this is what I have, which means that at x equals 2 and x equals negative 1, I'm going to have horizontal tangent lines. Okay. In the next one, it's asking you find all the points on the graph. Okay, because it is asking you for all the points on the graph, I would extend this further and I will actually find the points, meaning I will substitute 2 into the original function to find what is f of x. Okay, so let's see. 8 times 2 is 16 minus 12 minus 24 plus 4. So that is 4 minus 20, so negative 16. So if I didn't make any mistake, it is negative 16 is the y value. Then -1 will be -2 minus 3 plus 12 plus 4. So that's -5, -1, 11. So this is what I'm getting. You can check whether these values are correct or not. So these are the 2 points at which your f of x is going to have a horizontal tangent line. In the next, it's asking you, where does it have a slope of 60? So you repeat the same process. You take your f prime and set it equal to 60 now, okay? All right, and then I'm going to solve it. So I bring everything over to the left-hand side, and then I factor the 6 like I did before. Sorry. Right? Okay, and then I factor this further. All right. Okay, so that gives me at x equals 4 and x equals -3, I have tangent lines with a slope of positive 60. Okay. Now 72, wait, why is question 72 here? Okay, for some reason, 72 is before 63. That's okay. Let's do 72. The question is asking you find the equation of tangent line to the curve y equals x plus square root of x that has a slope of 2. So y prime is 1 plus 1 over 2 root x. Now I need to find out, okay, so I think I need more space for this problem. So I'm going to take this problem down after I'm done with 63 and 68. Okay, so let's do it in order. I'll do 63 first. Okay, so the 63, it's asking me find all the x values where the tangent line is horizontal. So this is similar to the previous problem we did. So what do I do again? I find f prime first. 4 times 1 over 2 root x minus 1. I simplify it, that is 2 over root x minus 1. So I set this equal to 0, okay? So which means that 2 over root x is equal to 1, right? So which means root x is equal to 2, x is equal to 4. Right? So x is equal to 4 is my solution. So that is the answer to part A. Now part B. I set this equal to -½ So I add 1 to both sides. I get 1/2. So this means root x is equal to 4 or x is equal to 16. Okay, so these are the two values that we get by solving the two equations. So setting the derivative equal to the slope of the tangent lines that they had given you. Okay. This is okay. All right. Next question. The question is asking you to find the first order, second order, and third order derivatives. So the first order derivative is nothing but 1/8 4x cubed minus 6x, which can be simplified to 1/2 x cubed minus 6x. F double prime is 1/2 3x squared minus 6. So I take the derivative of the first derivative to get me the second derivative. So this is 3/2 x squared minus 6. And the third order derivative is nothing but 3/2 of 2x, right? And that is 3x is the third order derivative. Now I'm going to copy question number 72 here and work on it. So 72 is find the equation of the tangent line to the curve y equals x plus root x that has a slope of 2. X plus root x that has a slope of 2. Okay. Um, they already gave you the slope of the tangent line, right? So what they have given you here, so let's do this. We have to find the x value, correct? The slope of the tangent line is given to you. So let's find y prime is 1 plus 1 over 2 root x. They gave you that, the slope of the tangent line at some x value, right? We don't know what the x value is 2. So this is given to you. So we are going to simplify this. 1 over 2 root x is 1 or root x is 1 half. Okay. So if root x is 1 half, x is nothing but square of that, which is 1/4. So then I have my x value. So in order to write the equation of a tangent line, I need all of these, correct? So what do I have now? I have the slope of the tangent line. I have the x value. Now I have to find the corresponding y value. So to do that, I just plug in 1/4 for x plus square root of 1/4. So 1/4 plus 1 half. So 1/4 plus 2/4, which is 3/4. Okay, so that is what is going to go here. So then I simplify this. Y minus 3/4 is 2x minus 1 half, or y is equal to 2x minus 1 half plus 3/4, which is plus 1/4. And that is the equation of the tangent line where the slope is equal to 2.